We're going to put the sun in the middle of a diagram here. And the sun's always giving off radiation in every direction. And as it goes around, Earth is always receiving the sun's radiation. Earth's orbit is elliptical, but the amount of radiation it's getting from the sun is essentially the same based on its orbit. What causes the seasons is that the Earth is not straight up and down compared to its axis, or compared to its rotation. The axis is tilted, and that tilt is 23.5 degrees. It means that, I'll put the equator on here while we draw this, it's tilted so that the northern hemisphere is tilted away from the sun here, and the northern hemisphere is tilted towards the sun here. So this would be summer in the northern hemisphere. That means we have longer days, more direct solar radiation. It's hitting the northern hemisphere, and warmer temperatures. On the other side, so that's summer on the northern hemisphere with the northern hemisphere tilted toward the sun. 6 months later, the southern hemisphere is tilted towards the sun. This is going to be summer in the southern hemisphere. I'm just going to say S-hem, but that's southern hemisphere. And they're going to have longer days, warmer temperatures, and more direct solar radiation during their summer, during which time it's our winter. So when it's summer in the northern hemisphere, it's winter in the southern hemisphere. They're tilted away from the sun. When it's summer in the southern hemisphere, it's winter up here. We're tilted away from the sun. And so some important dates. June 22nd, that's our summer solstice in the northern hemisphere. It's the winter solstice for the summer, or it's the winter solstice for the southern hemisphere. The summer solstice is our longest day. December 22nd is the summer solstice if you're in the southern hemisphere. And then we have these days called the equinoxes, where there's equal day and night for all hemispheres. One of them is in March. That's called the spring equinox. And one of them is in September. That's called the fall or autumnal equinox. Equinox. Okay. So you also need to know the phases of the moon. I'm going to block off my seasons diagram here. Maybe give it a little title. It's the reason for the seasons. We're going to talk about moon phases. So the sun and the earth and the moon together, there's going to be my earth. The sun, the earth, and the moon together cause something called the moon phases. But an important thing to realize about the moon phases is that no matter where the moon is in its orbit around the earth, it's always half lit up and half dark, just like every other celestial body, and the earth. Half lit up and half dark. It's our perspective from the surface of the earth that makes us see these phases. So, when we're looking at just the dark side of the moon, because the light side faces the sun, that's called a new moon. And when we're looking at just the light side of the moon, we see it as a full moon. as the moon orbits, we see a little bit from new to full. We see a little bit more of the full side every time, and it's always light from the right. You have your waxing crescent with a little bit of light on the right side. You have your first quarter with basically a half moon with the light on the right side. Then you have your waxing gibbous, which is not quite full, a little bit of darkness still on the left, but the light's coming in from the right side. Light from the right. And we go from new to full. Light comes in from the right side. It's still orbiting in this direction. After the full moon, we get what's called a waning gibbous. After the waning gibbous, we get our second half moon, but this time the light's on the other side, and that's called a third quarter moon. After third quarter moon, we got one more phase, and that's waning crescent. So after the new moon, the moon starts waxing to become full. When it goes from full to new, it's waning. Waning means going away. And it's always light from the right. A few more things to take care of here. Got to talk a little bit about the tides. So a tide is the rising and falling of the ocean or any large body of water. There are 2 high tides and 2 low tides every single day. And this is caused by the combined gravitational pulls of the sun and the moon on the Earth. So here's a new moon. Go lay down. In my diagram, we got a new moon here. This causes a tidal bulge to form along the Earth. This is high tide. The Earth is also spinning though, and your location will pass through 2 tidal bulges each day, and those are your high tides. When the sun and the Earth and the moon are not aligned, this would be during a first quarter or last quarter moon, your tidal bulge is always following the moon. And an important thing to know is your high tides are higher when it's full or new. So this is called your spring tide. And this is your first and your third quarter moon. This is called your neap tide. High tide's not as high during this time, and low tide's not as low. You have a greater range between high and low tide at the spring tide, a smaller range between high and low tide at the neap tide. To close out, we're just going to do a few things about space exploration, the timeline that you should be knowing. 1942 is your German V2 rocket reaches outer space. That's the first thing that humans are able to send outside of our atmosphere. 1957, you've got Sputnik. That's the first time humans are able to make something orbit the Earth. It's a Russian satellite. Kind of looks like a little bug, like a little circle with some legs. 61, is Yuri Gagarin. That's the first person to go into space. I said Yuri Gagarin. Yuri Gagarin. 1969, we have the Apollo missions, or the Apollo 11 is the first moon landing. That's when the US won the space race. In the 80s, we started seeing space shuttles, and space shuttles were the first thing that was designed to be reused in outer space. It kind of looked like an airplane, but there are some special things about it, like these tiles on the bottom that allow it to come back in without getting destroyed. So space shuttles are reusable. In the 1990s, we start seeing the Mars rovers. So we've got little remote control toys on another planet, driving around taking pictures. And then in the 2000s, we've got the International Space Station, which is where most of the research these days is still occurring. And I would say that's like the highlights of the space exploration timeline. Oh yeah, forgot to talk about eclipses. Let's talk about eclipses. There's a solar eclipse where the moon covers the sun, casting a shadow on the earth. There's two parts of the shadow. There's the umbra and the penumbra. If you're in the umbra, you get a total solar eclipse, so the sun gets completely blacked out for a little while. If you're in the penumbra, it's just a partial solar eclipse. So a solar eclipse can only happen during a new moon. A lunar eclipse happens during the full moon, and that's when the shadow of the earth covers the moon. And the solar eclipse doesn't happen every single time because the moon's orbit is tilted around the earth at 5 degrees. So sometimes the moon's a little too high or a little too low. They have to line up perfectly for there to be a solar or lunar eclipse. I think that's a lot of information. I think that's going to do it for this test. If you study hard, you're going to do well. And I will see you soon. Bye-bye.